This is day 13. We about to learn about structs in C++. Stand by. This video is about to start.
This is the Savage Scientist Ed right here, and I'm writing code in a police car.
Today we about to start talking about structs in C++. Structs is a very important thing. I know you're probably getting tired of me saying this is important, that's important, but almost everything about C++ is important. That's what I would say. So structs is something that actually comes from the C programming language. And like we know, C++ is just C with classes. And if we start talking about classes, then why talk about structs? So here go the topics for our video today. You already know what to do. All right, now it's time for us to jump into DevC++ so we can start looking at the implementation of our structs. So in DevC++, go to New Project. We're creating a brand new project, and we're going to name that project Structures. Let's type that in right quick, Structures. All right. And that's going to be a console application. So let's select console application right here. And if this pops up, just hit save. And now it's time for us to get rid of the command line arguments in our main statement. We're going to talk about that eventually, but let's get rid of those arguments and that other line with all that other BS in it. And now it's time for us to put our user namespace std statement in our code. That's what we use to get user input. Like we said earlier, a structure is a way to model an object. So a structure allows us to group multiple data types like ints, booleans, floats, all that good stuff into one convenient structure. And whenever we put our data types into that structure, like our floats and ints, we're going to be able to refer to that structure by its name and then create instances of that structure. It's kind of like the cookie cutter idea. We create our cookie cutter and then we start creating cookies. Let's look at our cookie cutters in a more formal way. We're going to look at it as a mode. Our mode creates several copies of the same thing. And this is our cookies here, also known as instances. So if the cookie cutter has an int x and y, so that means that each of our instances, C1, 2, 3, will also have an x and y component. So all copies or instances will have the same variables. So instead of creating cookies with our factory, let's create college courses. So we're going to model a real college course. At the University of Swampland, there's this English course called English 1110. 1 hour course that is hard as hell. That's what we're about to copy today. So don't be like me and fail it 6 times. So this is how we create our structure. You notice the struct keyword? That means we're in business. So we're going to start off with the name of our structure here. And it's going to be named course. And each course will have a course name, an integer value that holds a course ID, and a course capacity, how many people could fit in the classroom, a course cost, and the last element will be, is it a graduate level course? And I guess we could look at this factory. A course factory is called the universe. Our variables are within the curly braces, and it ends with a semicolon. Let's clear the screen. Now let's describe our variables. Right here we have our course name that's going to point to a character array. And our course ID, that's a 6-digit number that's used to identify our course. Course capacity is the maximum amount of students we can have in this course. And our model course will end with this Boolean value is graduate level. We're going to set it to a default value of false. So these are all the attributes in our structure called course. Now it's time for us to take our course cookie cutter and create some real courses. In the next video, we're going to get into a more formal terminology than using cookie cutter in fact. So let's declare an instance of our course. First, we're going to start off with the course structure name. And then we're going to put our name of our course, English 111. So now that we have our name of our course, or our instance of our course, we use the dot operator. Yeah, I said dot like that. We use the dot operator to access the individual components of our structure. Dot course name, dot course ID, and dot capacity, and dot course code. So what I'm saying here is, once we create an instance of our struct, The dot operator allows us to access the individual components like course name, course ID, course capacity, course cost is graduate level, all the things that we declared in our course structure. We use the dot operator to access that stuff. So what we are saying here is that English 1111 is a course and it has all these components, course name and all this stuff. And it's only English 1111. So we can't create something like instructor name. I'm sure you heard the way I talk. I don't think you want me teaching your English class. So we cannot create variables that doesn't exist in our original struct, like instructor name. So let's create a second course here. So we're going to call this one Janet's course because Janet will be teaching this English 111. So one day you might look back at these names and be in 111 and wonder who is teaching this course. So names like Janet in 111 is a better name because it adds a lot more information. Now we know who is teaching this course. It's kind of like the idea I was trying to do, but there is not an instructor name variable, so I won't be teaching this course. Let's get back to the course name. It's still going to have the English 1111 because that's part of the fields in our structure. So notice on line 7 where it says character, pointer, course name. And then line 18 and 25, we are assigning course name the characters English 111. That is an array of characters. We declared memory on the spot when we did that. We're going to talk more about that later. So let's move on. Course ID is next. That's a 6-digit integer that we're going to use to uniquely identify our course. So notice line 19. The course ID is 873291. We can't use that same number here on line 26. And now, Janet's Ing 111, we're about to access with our dot operator the capacity. And we're going to set our capacity to 100. Janet will be teaching a big auditorium style course. On line 28, we're about to set is graduate level to the same variable as Ing 111 is graduate level. And it's going to be false in both of them since we're using the same value. And now it's time for us to create a function here. Our function will take a structure and print the values. That's all it's going to do. Let's start with our return type, void. A void return type just means that our function will not return a value. And notice our input parameter, course. Just like int or boolean or some other type of parameter, we are accepting only course structures. So it's time for us to start printing these values. And notice on our line 16, input course, dot course name. We are using the dot operator on the input variable. It works just like any other thing. If we had int x, then we are accessing int x. So using a structure is one way that we could return many data types or accept many data types into our function. So line 19, we are still continuing to print the components of our input course. And now let's finish up with our coast to coast. Put our inline here. Next, so you got your degree. Now it's time to go to grad school. You're taking a grad course, huh? Well, in C++, whenever we print Boolean values, it's going to print 0 or not 0. So look at our results after running our program. Remember, hit F11 and check it out. We have our course name, English 111, course ID that matches English 111, course ID, and all the rest of our values are printed. But take a look at the Boolean value, graduate course, 0. So that means it's false. And look at graduate level in our code. It says false. So that's what I mean by Boolean prints 0 if it's false and 1 for true. Now it's time to move on and print the course details for my girl Janet's English 111 course. And we're still going to leave the original English 111 course information up here. So let's take a look at it. So as you can see, the course IDs are different and the price And capacity is different, but take a look at that price, the cost. The cost of this of Janet's course is expensive. I guess Janet Jackson is teaching it. So now it's time for us to move on to another example where we're about to declare a struct a different way. So first, I want you to notice the typedef keyword. Typedef is just meaning that we're defining a new type. So we're going to start with typedef, and then we're going to put our struct keyword immediately following typedef. And then after the closing bracket, we're going to put the name of our structure. We spelling course with a capital C now, and check this out. C21. We giving our structure two names. So we could declare structures now with both names, course and C21. And now it's time for us to see this in action. Since we changed the name of our course, now it's spelled with a capital C, we have to change it in our function. And now it's time for us to take a look at what we're doing here. So this is how you declare a struct using this second method. Typedef struct, put our variables in the middle, and then you notice we have our course spelled with a capital C and our alias C21. So on lines 27 and 34, notice how we have lowercase c's for our course. We changed that to a capital C. So let's fix that one on line 27. And on 34, we're about to use C21 the same way. And let's see if our function's gonna work. All right, so let's capitalize this C and get rid of all this stuff. We're gonna change this to C21. All right. So let's compile and run and see what our results look like here. So our results showing that everything is exactly the same. So we declared one using C21 and we declared another course using course. And it performed the exact same way we expected. That's the beauty of using structs. So let's review structs again right quick. We basically use the struct keyword and then our structure name. And we're going to put our curly braces and our variables in the middle of the body of our structure. And then we're going to end with a semicolon. The second way we declare structure is use typedef, struct keyword. And then we're going to put our variables in the middle of the body, just like we did last time. And our struct name will be at the end. And then any alias will be at the end. Those aliases work almost like references in C++. So, in this example, we're about to create two incompatible structures. We're going to call one car. Car is called Bonneville. And that structure will be separate from our phone structure, which we're going to use our second method. So we're going to create V60 and V70 to mess with Eazy Computer solutions. So we cannot assign a Bonneville to a phone. That's two different structures. So this video is finished. We learned about structures today. And tomorrow we're going to learn about classes. And you're going to get a chance to see how closely related classes are to structures. Structures are some old C language stuff. So it's one of the reasons why C++ is such a powerful language. When you program in C++, you also have the ability to use the things that's in C, like structs and all kind of other C stuff. So we're about to get into classes tomorrow on day 14. So this is Savage Scientist Ed. Till I make my next video. Peace out.